Welcome class. Today's lesson is about the scientific method. Before we begin, let's discuss science. Science is a way to answer questions and solve problems, how we understand the world around us, in a way we process and investigate what is happening around you. It also provides you with possible answers. We answer our scientific questions and solve our problems by using the scientific method. Here are the steps in the scientific method. We identify the problem. We ask questions, figure out what our problem is, and then we form a hypothesis. From there, we use a procedure to test this hypothesis based on experimental design. We make observations, measurements, and record data. We analyze that data to make a conclusion, which basically is a yes or no answer to our hypothesis. When we identify the problem, we ask our questions, we collect information, and from that information, we form a hypothesis. Sometimes this information comes from research from other scientists, sometimes it's from our background knowledge, our experience in life. So when we form a hypothesis, what we're doing is we're just making a statement, describing our educated answer to the question we pose. When we follow our procedure, we test the hypothesis by using experimental design, or sometimes we call it a controlled experiment. So what is this experimental design or this controlled experiment? We have variables. We test the hypothesis. We use control groups. We have a set of planned steps, and we test one variable at a time. So let's talk about the three types of variables: independent, dependent, and controlled. Independent variable is basically the variable that we're going to change during our experiment. This variable may affect or change our dependent variable. Independent variables are factors that are being measured in our experiment. They may change because of the result of the independent variable. And our controlled variables, our variable, is our constant. These are the things that we're going to keep the same between our experimental groups and our control groups. This is a variable that stays the same in our experiment. So examples of a few things we talked about. Let's give you a problem. Will the temperature of water affect how fast an egg will boil? We collected data from the past experiences in our life, and we form a hypothesis. The higher the temperature of water, the faster an egg will boil. So let's look at our independent variable. This is what we were changing in our experiment. The temperature of our water. The dependent variable is the time it took to cook the egg. That is what we measured. And some of the control variables we have was like the type of egg, how much water we put in the pot, the size of the pot, etc. After we perform our experiment, we want to observe, measure, and collect data while we do our experiment. So how do scientists observe? They use their five senses: hearing, touching, smelling, sight, and taste. Most of what we're going to be doing this year involves sight. When we measure data in the lab, we use scientific tools such as triple beam balances, graduated cylinders, meter sticks, and we also report our units in the metric units such as grams or liters. How do we record our data? We record our data in tables. We have a descriptive label. We divide them into columns and rows. We show our independent variable, and we record our information on our dependent variable. We take that data and we analyze it. So what do? We reduce the data with the best measure of central tendency. We graph the data so we can visualize the information. We look for patterns and relationships and shapes on the graph. What do scientists do when they draw conclusions? When the scientists draw conclusions, basically they are answering the original question. They're stating whether or not the hypothesis they proposed was supported. Okay, was it right or was it wrong? And after that, they pose questions for further research. When experiments are done, they need to basically make sure their data is correct. So they repeat the trials. Why are these repeated trials necessary? To make sure the results are valid. The more trials that are conducted, the more likely the results are valid. And to make sure we don't have a fluke, okay, in our experiment, it is not considered a true result. Let's take a look at a video that helps us explain a little bit more about experiments.
Hurry to Lowe's and find big summer savings for this 4th of July, like this Charbroiled Advantage Black 3-burner gas.
Okay, so in this quick video here, we're going to go over the basic differences in a science experiment between the independent variable versus the dependent variable. You know, every year when I do science experiments, it seems that I still have a number of students who at the end of the school year are kind of still mixing the two up. So hopefully this video will be a little helpful. Here we go. So when we go into the independent and the dependent variable, we need to examine the two major parts of a science experiment. And you might know that one part of an experiment is called the control group, and the other part is called the experimental group. Well, what is so special about the control group is really nothing at all. The control group is the part of the experiment that receives no special treatment. And the purpose of the control group is it's going to give us some data, and we're going to use that data. We're going to compare that data to the other group. We're going to compare the data of the control group to the data of the experimental group. So if the control group receives no special treatment, that means whatever we're testing, the experimental group is going to receive. And so the experimental group is the part of the experiment. You set them up exactly the same, the experimental group and the control group. But the experimental group is the part of the experiment that receives whatever it is you're testing. And whatever it is that you're testing is what we call the independent variable. It's the one factor that's different from the control group. It's what you're testing. Let's see if we can go over a simple example. Here we have a picture of a young lady sleeping. Let's pretend that she wanted to know what effect does music have on the ability to sleep through the night. So what we're going to do is we're going to set up an experiment. One group of test subjects are going to listen to music while they sleep. One group of test subjects are not. Let's go through that right now. So when we set up a control group and an experimental group, you see that we keep them exactly the same. That means both groups of test subjects, whether it's only one person or 50 people or 100 people, let's say that we have 50 people in the control group and 50 people in the experimental group. Well, we're going to make sure that they have a nice, comfortable bed to sleep upon. Both groups, we're going to ask them during the day, both groups, we're going to ask them to do fairly similar physical fitness and, try and stay in good shape, practice good health. Both groups, we're going to try to balance out their diet, have a well-balanced meal, carbohydrates, proteins, lipids, and we're going to try, notice how the two groups are exactly the same so far. And then the one thing that's going to be different is, okay, the experimental group receives the experimental factor. In this case, whether or not they get to listen to music while they're sleeping. Now, please note that this example is fairly simplistic. Yes, there are other experimental factors we would need to set. The age of the participants, the gender of the participants. Again, we're just kind of going over the broad concept right here. And so after the experiment is finished, let's say that you record the amount of sleep that the two groups achieve for a month. And over the course of 1 month, the control group, who did not get to listen to music, they slept continuously for about 6 hours and then they woke up. But then the experimental group, they slept continuously for about 8 hours. And so when we look at this data here is what we call the dependent variable. The data that you collect, your results. The reason it's called the dependent variable because the sleep depended on, the amount of sleep depended on whether or not they had music. The dependent variable depends on the independent variable. And so that's why it's called that. And so anytime you're measuring data in a science experiment, the data that you collect is your dependent variable. over another example of something. Is this a good experiment? Again, I haven't changed any of the text, but watch the pictures that show up. Let's say, again, you're going to do the sleep and the music experiment. And so, again, all the test subjects of the control group get a nice, comfortable bed. All the test subjects of the experimental group get a nice, comfortable bed. During the day, however, you have them perform different exercises. During the day, you have them consume different kinds of food. And then when they sleep, the experimental group receives music. The control group does not receive music. And let's look at the data. After 1 month, pretend that, just like last time, pretend that after 1 month, the control group, on average, slept for about 6 hours before they awoke. And the experimental group slept for about 8 hours before they awoke. I hope you see a problem with this experiment here. This experiment, the results of this experiment would be invalid. This experiment has too many independent variables. There's too many things that have changed between the control and experimental group. Not only have you changed the music, you also changed the food that the people eat and the activities they perform while they're awake. Those also could cause people to sleep longer. Perhaps the meals that you're eating are allowing you to have a better night's sleep. Maybe you're just more tired because the exercise is more strenuous, and that's why you slept a total of 8 hours. Maybe you slept longer, and music had nothing to do with it. So this is why a good experiment only has one independent variable. Well, here, go over a couple examples. Watch this. So here we have some Army soldiers, and here's a fictional experiment here. And it says, the United States military wants to see if soldiers with only 4 hours of sleep can operate at the same level as those who normally get 7 hours of sleep. 100 soldiers are allowed to sleep for 4 hours a night, and another 100 are allowed to sleep for 7 hours a night. During the day, the soldiers are tested for marksmanship on the firing range. Well, try to answer these questions. Name the control group, experimental group, independent variable, dependent variable. Pause the video. Pause the video. I'm going to go over the answers in 3, 2, 1. All right, so for the control group, these are the test subjects that receive the normal. And it's normal to get about 7 hours sleep. I think that's pretty normal even in the military. What's abnormal, what's different, is the experimental group. And in this case, what's different are those who may only get 4 hours of sleep. And so when you look at the next part, name the independent variable. The independent variable is what's been changed. What's different between the two groups of test subjects? What's different between the two groups of subjects is the amount of sleep that they are given. And then the last one about naming the dependent variable. Remember, the dependent variable is the data that we collected. How do we know if sleep affected them? What data are we collecting? In this case, the data we're collecting is the score on the firing range. Can they hit the target well? Can they hit the bullseye? So here's another example. In this example, here we have this farmer right here, and this farmer is going to be testing his fertilizer. So here's a picture of the fertilizer that he normally uses to grow his crops. Here's my little story here. Farmer Bob wants to test a new fertilizer to help his crops grow better. He sections off 2 large areas of his field. In section A, he waters his crops as usual and uses his normal fertilizer. But in section B, he waters his crops as usual and adds an experimental fertilizer. So after 1 growing season, he records the growth of the crops. So just like the last example with the Army soldiers, pause the video and try to answer these 4 questions here. Pause the video. I'm going to go over the answer in 3, 2, 1. Okay, so identifying the control group. Remember, the control group is the normal. And in this case, the normal section of crops is section A. Remember, the experimental group is something that we've changed. We've done something different to the experimental group, and that would be section B of the farmer's crops. And so name the independent variable. What's different between section A and section B? There should only be one thing different. If you have more than one thing different, you have a badly designed experiment. But in this case, there's only one thing